Welcome to All This Math. This is our Instagram Live for tonight, and these two problems up here on the board were sent in by my little cousin Isaiah down in Baltimore. Shout out to Isaiah. Now, for everybody else that's looking in, you see all these words up here, right? And all these words up here, right? The first thing I want to say is, do not be intimidated by word problems. Do not let word problems bully you, okay? Word problems are an excellent opportunity for us to merge reading comprehension with mathematical competency. That's all it is, all right? Like I used to often say to my students, and I still say this to my students actually, used to say, I still say it. You got to be able to read before you could do math. Because you got to be able to read the question and understand what you're being asked to do. All right? So do not let word problems bully you. Do not let word problems intimidate you. Attack the word problem. Break it down. Pull out the information that you need. And then get yourself to the answer. All right. Now we have two different word problems up here. I'm going to go over this one first. And then I'm going to go over this one over here. All right. Now, apologies if you cannot understand my handwriting. If it's not legible enough for you, I'm going to read the problem out loud anyway. Okay. So, this first problem says that Jody spent 25% more buying her English reading book than Claudia. Then he put somebody else in the mix, Gianna. Gianna spent 10% less than Claudia. Then the question is, Jody spent more than Gianna by what percent? Now that question is worded a little weird. So what they're basically asking you to do is to compare how much Jody spent to how much Gianna spent. But you have information about Jody and compared to Claudia, and then you have information about Gianna compared to Claudia. So, first thing I would say is this. If you ever are given a word problem like this, where something is more than something else, or something is less than something else, or somebody is half as old as this person, or somebody has this much, twice as much money as this person, when you ever see comparison word problems, my suggestion is we create variables. Now, we need a variable we need to represent one of these items, one of these people in this case, should be represented by X. I always say the person or the thing that's being compared to, the second thing should be X. So for example, in the first sentence, we got Jody compared to Claudia. Jody was first, Claudia was second. So that means I'm going to call Claudia X. And then Jody is in comparison to Claudia. All right? And in the second sentence, I got Gianna and I got Claudia. In the second sentence, Claudia is still second. So I'm going to still use X, right? So this is how it's going to break down. So on your paper, you should do this. We got three people we're talking about, right? We got Jody. We got Claudia. And we got Gianna. Now the key is, as you listen to me explain this, I hope that whenever you see a problem like this ever again for the rest of your life, you'll remember, okay, this is how I do that type of problem when I see that type of problem. Just like when you play in a video game. When you get to a certain level in a video game or you're in a certain space in a video game, if you've played that game enough, you recognize the pattern. You know what you have to do to beat that level of that video game. So whenever you play that video game and you get to that point, you know to do the same thing every time if you want to win and if you want to beat that level. The math problems are the same way. Whenever you see a problem that looks a certain way, you automatically remember something should trigger you. Oh, that's right. When I see these problems, this is what I got to do. So dig this, right? We got Jody compared to Claudia. So Claudia is the second person, right, in the comparison. So I'm going to call Claudia X. So now think about that. It says that Jody spent 25% more. Let me underline that. 25% more. That word more. Think to yourself, does that mean addition, subtraction, division, multiplication? What does it represent? It's going to represent addition. Because however much Claudia spent, Jody spent more. So you would take the amount Claudia spent plus 25%. So I'm going to call Jody, I'm going to represent Jody with another expression. I'm going to represent her as x plus 25. So now Claudia is x. Jody spent 25% more. So that more is plus 25. All right? Now down to Gianna. Gianna spent 10% less than Claudia. So let me underline that. 10% less than. That's also important. Now, more meant that we needed to add. Less than, what does that mean? Less than means we need to subtract. Okay? We got to subtract for less than, right? Now, but are we doing 10 minus x? Or am I going to do x minus 10? That's the question. Think about it. 10% less than this. So if I'm trying to represent less than this by 10, then I'm going to write x minus 10. I'm not going to write 10 take away x. I'm going to write x minus 10. See, the language can be confusing because, look, it says 10% less than. Now, if you think in your head, well, oh, I know less than means subtraction, right? And the 10 is written first. So it should be 10 minus. So you might be thinking, oh, well, that means I do 10 minus x or 10 minus Claudia. Nah, it's not like that. We got to know how to translate the English language into math language appropriately. Just like if we were going from English to Spanish or Spanish to English, it seems like in some certain other languages, something might be stated backwards compared to English. Or to people that speak another language, English might be written backwards compared to their language. Mathematics is the same way. So even though this says 10% less than Claudia, it doesn't mean 10 minus Claudia or 10 minus x, since Claudia is x. We're talking about in comparison to Claudia. So 10% less than Claudia, think about it in terms of a real life situation. If you have $5 less than me, that means that to calculate how much money you have, if you don't already know, you would take my amount of money and subtract 5 from that, right? So it'd be my money minus 5, not 5 minus my money. All right? So these are our representations for the three people, right? Now the question is, Jody spent more than Gianna by what percent? So basically we're saying, how much more did Jody spend than Gianna spent? How much more did Jody spend than Gianna spent? So to me, that sounds like a more than question. And when we deal with more than questions, we're dealing with subtraction. More than questions mean that we're dealing with subtraction. So we're going to subtract Jody's amount that she spent minus Gianna's amount that she spent. So this is the algebraic way to do this, right? So I'm going to do Jody minus Gianna, which equals x plus 25 minus x minus 10. Now, I did something wrong here, purposefully. I left something out. Because I'm subtracting the entire Gianna's dollar amount that she spent, I can't just put minus and then x minus 10. I have to put that entire expression in parentheses. If you leave out the parentheses, your answer will be wrong. Straight like that. Your answer will be wrong. Because what that implies is that you're not subtracting this negative 10. You're only subtracting the x. Now that I put the parentheses around this, I'm subtracting the entire amount represented, or the entire expression that represents Gianna's amount of dollars spent. Now I can get into the algebra. So now this negative sign gets applied to both of these terms. So it's kind of like using the distributive property. This is like a -1, basically. An invisible -1 multiplied by both of these terms, right? So I can rewrite this without the parentheses because I need to have the parentheses in the first place in the beginning, but then my goal is actually to eliminate the parentheses and simplify this whole expression. So I'm going to rewrite this as x plus 25, -1 times x minus x. -1 times -10 plus 10. Now I can just combine like terms, right? So I'm going to combine the x's and I'm going to combine the constants. So x take away x is 0. They cancel out, which is cool. The x's can cancel out. And then I have 25 plus 10. Keep in mind, this minus sign has nothing to do with this 10. The sign in front of, or the operational symbol in front of this 10 is a plus sign. So that means we're doing 25 plus 10, which equals 35, or 35%. So the answer to the question is that Jody spent 35% more than Gianna. Now, let's say I didn't know how to do algebra. Let's say I don't like using letters in math. Let's say whatever. Let's say we want to look at this intuitively. There's another way to look at this. Actually, there are probably several ways to look at this. And that's another thing about math that's beautiful, really, that we don't have to be committed to just one way of doing a problem. Sure, you can learn one way to do a problem. And if you're comfortable with that, you can use that method every single time you see that type of problem. That's cool. But there might be 5 or 6 or 7 different ways to do a problem. And on a Monday, you might be in the mood for this method. On Tuesday, you might be in the mood for a different method. On Wednesday, a different method. And all that is cool. Just make sure that your steps are mathematically correct and they're mathematically sound. That's all I'm saying. So here we have 35%. This is the answer. Now, why does this answer make sense? Because think about it. Let's say Claudia, right? She's the most important person in this scenario. Let's say the amount of money she spent, let's say that's 100%. Let's say Claudia is represented by 100%. Right? Now, if Jody spent 25% more than her, right? Then that means that Jody spent 125%. And if Gianna spent 10% less, then that means you do 100 minus 10, which is 90%. So now the question is, Jody spent more than Gianna by what percent? So Jody compared to Gianna. Jody compared to Gianna. 125 compared to 90. What's the difference between 125 and 90? 125 minus 90 equals 35%. Boom. Either way, you get 35%. So to answer the question, and if this is online, just click the little circle. Or if this was an actual word problem on notebook paper, or on that you had to hand write out, like a constructive response question on a standardized test, you would say, Jody spent 35% more than Gianna on her English reading book. You know? So Gianna got the best deal, though. Gianna should have, she must have comparison shopped, did a little bit of internet searches or whatever, Whereas, Jody might have been on some last minute type time and just needed the book real fast and just, boom, just went online and just did a search and just grabbed the first drawing and she could see. So, that happens. But, so that's the answer to this first question. 35%. All right. Now, let's direct our attention over here to the second problem. Also sent in by my little cousin, Isaiah, down in Baltimore. All right. I'm going to switch my color up. We use blue. Just to switch it up. All right, now, let's read this out loud. This problem involves mixtures, solutions. This is really a science question. All right. But again, you have to use mathematics in order to come up with the answer. But it's a science question, right? You might actually encounter this real situation in school in a chemistry lab, or in your house when you're cooking dinner or lunch or breakfast or whatever, right? Or actually, not even, because you can use vinegar to clean as a cleaning agent a lot of times. So you might be using this, you know what I'm saying, just in your household chores, all right? So anyway, problem says a mixture is made when 10 milliliters of a 25% vinegar solution is combined with 15 milliliters of a 45% vinegar solution. What percent of the combined mixture is vinegar? All right, so just let that sit with you for a minute, because again, we have to be able to read before we do math. And when I say we have to be able to read, we have to comprehend what this really means. So a mixture, right? When you mix two different liquids, all right? Because we're talking about liquids, right? Fluids here, right? Liquids. So we're talking about mixing either 2 or 3 or 4 or 5. A lot of times, if you're making a certain type of juice or a certain type of beverage, you may mix several different things, right? Here, we're talking about a vinegar solution. Now, this 25% vinegar solution, what that means is that in that container, in that bottle, 25% of that bottle is pure vinegar. The other 75%, because everything in the bottle has to add up to 100%. Let me say that again. Everything in the bottle has to add up to 100%. So if it's a 25% vinegar solution, that means that 25% of the bottle is vinegar. And then the other 75% might be water, might be sugar, might be salt. It might be, some other chemicals, to make it last longer, whatever. It might be, I don't know, some other ingredients to make it taste better if it's something that's being ingested or digested, whatever. But 25% of that is vinegar. All right. Also, 25% can also be converted to a fraction. 1/4, a quarter. 25%, 25 cents. 25 cents is a quarter. All right. So, in this 10 milliliter solution, 25% of it is vinegar. Now, we're going to combine this with 15 milliliters. That's a different amount. This bottle had 10 milliliters in it. This bottle has 15 milliliters in it. But in this other bottle with 15 milliliters in it, we have a 45% vinegar solution. So that means that in that bottle, 45% of the liquid is vinegar. And then 55% is everything else. It might be 55%. The other 55% might be water, might be sugar, might be salt, might be whatever, might be other ingredients. But altogether, everything has to add up to 100% in each bottle. All right? So now what they're saying in this problem is that what percent of the combined mixture is vinegar? Combined. All right? Combined. That means we add them together. Combined mixture. That's key. That's key. Now, again, there are different ways to approach this problem. This is how I approach it. First thing I would do, I'm going to add up the total amount of solution that I'm going to have, right? So the 10 milliliter solution plus the 15 milliliter solution. So this is what I'm going to do. And I suggest you write this down. You do 10 milliliters plus 15 milliliters. And what's 10 plus 15? 25, right? So you got 25 milliliters, right? So altogether, now we got a different bottle, different container. We combine this solution with that solution. Now we got 25 milliliters altogether. So now what we want to find out is what is the percent of this 25 milliliters that's going to be vinegar. Now, one way to do this is we go back to each individual, right, bottle and find out not the percentage, but actually how many milliliters was vinegar in the first place. How many of those milliliters, how many of these 10 milliliters was vinegar? And then how many of these 15 milliliters was vinegar? Then once we know that, we can add them together and then we can find a percentage that it is out of 25 milliliters. And then we'll have the answer to the question. So dig this. We want to know 25% of 10 milliliters. What's that? Okay. You can do this mentally. If you just have the percentages memorized, you know that 25% is 1/4, right? So if you know 1/4 of $10, you might think, okay, well, $10, I know 1/4 of $1 is 25 cents. So 1/4 of $10 would be $2.50, right? Now, if you don't have that memorized, that's cool too. You can just do this. Convert 25% into 0.25. The word of, again, because we're talking about language. We're talking about language. This is the English language. We're converting into math language. So the word of means multiply. So 0.25 times 10 is equal to, like I said, 2.5. And we don't want to forget your units. You want to have your units at all times. So that's 2.5 milliliters. So that means, what does that really mean? I'm about to tell you. So in this bottle that had 10 milliliters of liquid, 2.5 of those milliliters were vinegar. So that means that 7.5 milliliters was all that other stuff. But we only care about the vinegar right now. So we know that 2.5 milliliters from this bottle was vinegar. Now we're going to do the same thing for the 15 milliliter bottle. Check this out. You're going to do 45% of 15 milliliters. So I can convert this. 0.45 times 15 equals 6.75. How do I know that? Because I did this problem earlier in preparation for this, right? But another way I would know it is this. You can take 10%, it's a little percentage trick that I'm going to show you real fast. You can take 10% of anything and figure out what the percentage is. So 10% of 15 is going to be 1.5. But I need 45%. So isn't 10% times 4 40%? So that's 6.0 right there. So that's 40% right there. Because 10% is 1.5. 10% times 4 is 40%. So that's my 6.0. That's 6.0. That's not all of it though, because I need 5%. But then check this out. Isn't 5% just half of 10%? So if I know that 10% was 1.5, I can take half of that, which is 0.75, and then multiply that by 1, and that's 0.75. And this is for like mental math. So when you like shopping, you in the store, you know, and you trying to calculate, you know, your discount off or how much your tax is going to be that you have to pay extra or whatever, you know. So you don't got to be in the store like, because, you know, you're in the store, you want to do your math quick because you don't want to have to pull out a calculator because then you feel like, you know, the store owner might try to take advantage of you because they think you don't know how to do the math. But if you could do it in your head real fast and then you just come to them like, boom, like, nah, I don't agree with the numbers that you came up with. Use this method. 6 plus 0.75 is 6.75. So that means you have 6.75 milliliters. So now, back to this problem. In that 15 milliliter bottle right here, we have 6.75 milliliters worth of vinegar, right? So now, because we mix these two bottles together, altogether, how much vinegar do we have? All you do is add 2.5 plus 6.75. 2 and the 6 gives me 8. And then think about it like money, 0.75. What if this was $2.50 plus $6.75? We should know how to add that. $2 plus $6 is $8. 75 cents plus 50 cents is $1.25, right? So 8 plus $1.25 is going to be $9.25. Whether it's money or whether it's amount of liquid in a solution, it's the same mathematics, right? So now we're saying that we have 9.25 milliliters of vinegar inside of this solution from the mixture. When we mix the two containers or mix the two solutions together. Now the question is, what percent is vinegar? So now the question is, 9.25 is what percent of 25 milliliters? Again, why am I worried about 25 milliliters? This is why. Because the one bottle had 10 milliliters altogether. The second bottle had 15 milliliters altogether. So that means when I combine all those, I should have 25 milliliters. So now in those two bottles, 9.25 milliliters of those should be vinegar. So now we just got to come up with the percentage. So all you got to do is this. 9.25 divided by 25 milliliters equals 0.37, right? Units cancel out. Now, we have to convert this to a percentage. So we're going to do 0.37 times 100. 0.37 times 100 is going to give me 37%. So that means that in this new solution, 37% of that is vinegar. Now, notice how in one of the bottles it was 25% of it was vinegar. The other bottle, 45% of it was vinegar. Notice how 37 is a little closer to 45 than 25 though, right? Why do you think that might be? Because in the bigger amount, the bigger container, the larger container had more vinegar in it. The smaller container had less vinegar in it. So it would make sense that when you mix those, you would have an amount of vinegar that's closer to the amount that was in the bigger container than in the smaller container. So at any rate, the answer is 37%. That would be the percent of the mixture, combined mixture, that is vinegar. All right. Isaiah, I hope this helped. And for those of y'all watching, please continue to send in your math questions. Take a picture of them, send them to the All This Math DM at Instagram. Follow me on Instagram if you're not already. Tell a friend to tell a friend. Follow me on Instagram. Every day I go live at 10 a.m. and 6 p.m. And when you send your problem in, it might make it to this board. Peace.